it's going to do a little echo thing for a second. And,
Is it up live?
Yeah, I'm seeing it on my screen, but it takes a second to get it into like my channel and all that. Then we just wait. It's funny, every time we start this, it probably looks like we're out of our minds, like.
Trying to get everything set up.
Yeah.
Okay, there it is, live now, because then I have to turn off the volume, right?
Yep. Same old spiel. Yeah, sometimes it comes up quick, sometimes it does not. I guess it depends on how much, Yep, I found it. Did you find it yet?
Mm-hmm, just got to turn the volume off.
Yep, I found it.
Okay.
Did you find it yet? Okay, good. You're working, I'm working. We're all working. And we'll just wait for folks.
4 watching, so 2 people are here, aside from us.
Well, I'm signed in, to 2 places, and you're signed into 1, so I think we have 1 person.
Okay.
We'll just wait it out a little bit. Bam. Maybe we'll try doing the Brady Bunch style, where I put you over my head, so I can do the whole, like, looking up thing. I wonder if this would be better for notes.
That's funny.
And then I make myself a little smaller. There we go. And there we have it. How's it look in the live feed? Oh, that looks good. That might be better. Always optimizing. Oh, I guess we'll just wait a minute or 2. Oh, no, there you are. I think you're good. Wait, oh no. I see. I can't take it out of that window.
No, because then I don't see myself. There I am.
Now you're good. Yeah, it's a weird way that works with the software I use. It focuses on a window, so if I put a new tab in the window and I change tabs, it like changes what's displayed.
Gotcha.
So 2 people watching, and that's both of us.
Is that us? They were there and then they left. They don't want to hear our conversation.
Well, I guess maybe we just do it then.
Yeah, I guess so.
Well, here we go. Howdy, folks. You're watching this without a live audience, but that's all right. Once again, if you tune in later, absolutely fine. So today we are going to just take a little glimpse over glaciers, talking about those big icy things that you probably are pretty familiar with. But from a science standpoint, the definition of a glacier is a large, long-lasting mass of ice which forms on the land and moves downslope because of gravity. Really important that we mention the long-lasting, because we can get sheets of ice where we are. You know, you could have ice that lasts for a couple of weeks, but it's not a glacier unless it's really big and it's been there a while. So we're talking multiple seasons. We're talking living through the summertime and getting to another period of, getting more snow in the winter. So that is what a glacier is. And these things can be huge. They can span, like multiple states. They can be just ginormous and super thick too. They could be, 100 feet tall or so. And just, it's interesting to think of how much ice that actually is, especially if it's that wide.
Yeah, I think that's hard for us to visualize because it's not something that we see on a daily basis.
When in doubt, what's that animated movie? I think it's literally called Ice Age, right? They've got
Yes.
all sorts of glaciers in that, right? And you can see they're giant walls, and there's different types of ice. Those in those animations, I think they're just pretty white, like it almost looks like snow. But if you look at real world glaciers, you'll see that there's actually different parts of a glacier, and we'll get into that a little later. But it still might give you a better idea of what they look like. So go ahead and go watch Ice Age. You've got nothing better to do, right?
Exactly. And they're fun to watch.
They are. They're actually pretty funny. I love the little squirrel. That gag never gets old.
No, definitely not.
So how does a glacier form? Well, it all starts with snow, right? So the same snow that falls here is going to fall somewhere where it stays colder more of the year. And it's going to build up and build up and build up. And it's going to eventually become these little clusters. We call those granular snow. So it starts off in flakes, and with a little bit of pressure from snow building up and just the conditions that exist there, they will become these like little clumpy ice balls. Then, over time, that gets compacted more and more and more, and you get what we call firn. I've got a picture of that in the next slide. And then, after a while, you start to get the real clear glacial ice. So it takes a lot of time, and it also takes a lot of pressure. The compaction is what takes all these crystals, which there's space right in between the flakes. Even if you look at the picture, there's all this space that exists in between the different pieces of ice, the little strands. And because of the compaction, it slowly gets rid of that airspace, and that's why it looks more thin, clear and like glass almost, right? Because it's all together, there's no spaces. Now there are some spaces, it's not perfect, and it's kind of cool because you can get some ancient dust and gas trapped inside, and they take ice cores, you might have heard of that before, and they can actually test those to see what it was like really, really long time ago. So there's some pretty interesting things with glaciers outside of them just being so enormous. So here is what that firn looks like. It almost looks perfectly clear, but you can still see it's a little hard to see through. Glacial ice is going to be more like bluish and solid. Again, think like window glass, but maybe with more of a tint. It also depends on what's trapped in the ice. If it's like really, really dirty, you might see that it'll have more brownish colors from sand or sediment that's been trapped in it. But overall, it goes through those phases of being snow to this granular, like snowball kind of ice structure, to this firn, which is almost, totally transparent but hard to see through, and then it eventually gets to that glacial ice, which is really old. It's been under a lot of pressure for a long time, and it's actually flowed to make this more smooth appearance and texture.
We have, I think that's Ryan in the chat.
Yep.
Ryan, you don't necessarily have to write anything down. It's just for you to listen. And if you want to go back at some point and write vocabulary down, you can, but we're not requiring you to take notes or anything like that. Only if you want to.
And if you really want the notes, you can always go to Astro's page, help me here. E-board, there we go. It's been a while. You can go to the e-board, and there are completed notes that you don't even need to write on. So if you want to just have the quick notes, you can get them there.
Yep.
So, two types of glaciers we'll talk about. Both have to do with being on land, not talking about the glaciers that are in the ocean, but they are alpine and continental. So the ones that are alpine, I don't know if you've ever heard of the word alpine, but usually it's associated with mountains, right? So these are the glaciers that literally form in or on a valley, or in the valley of a mountain, rather. So you can see here's your mountain, and you can get the smaller ones, they call them cirques, or you could have these larger ones that kind of sit just in the valley of where this mountain is kind of bending downwards. Then you have the other one, which is just on flat land. We call those continental glaciers. And they're just nice and flat and large. And they don't sit up anywhere in the mountains. They just sit on up, like a plains. So
It's kind of weird to do this without a couple of people here.
yeah.
Questions.
Well, they'll watch.
Yeah, no, I know.
But I agree. So, question would be, what kind of glacier is this? And it's maybe a little hard to tell. It's not the flattest area of all time, but this definitely is in a flatter area than one that would be in that cradle of a mountain. So this would be more like a continental glacier, pretty flat. This is definitely some fresh snow on top. And this would be more of an alpine glacier, with these glaciers forming inside of the little areas of the mountain that let them, sit and develop.
And again, both these types of glaciers, you have to have extreme cold weather. It's not just like a snowy season and then the glacier. It's years and years of cold weather.
Mm-hmm. And it's got to be in a place where it doesn't have, like if you think of our summer gets really hot. Even though we sometimes, not this year, but we sometimes do get a lot of snow, it has to stay there through the summer. So there needs to be enough snow that builds up so that even though some is going to melt, it still stays. And then on top of that, however long those melting days exist, they're probably much, much shorter than our summer. So this is why you're going to find glaciers usually at the higher latitudes, but also you can find glaciers at high altitude, right? High up. That's why you see sometimes, and I think we had a few questions on our tests when we were looking at climate, that you do find the snow-capped mountains even on the, near the equator, just because they're so high up. So it's definitely got to be cold, and for a long period of time. Alright, so when talking about, when talking about glaciers, another important thing about them is that they're not just like an ice cube that stays the same the whole time. They're not just this one big hunk of ice that never melts. They are constantly getting refueled with new snow at the top, and then they are melting at the bottom. So there's and it's not super fast, but there is a flow of this ice over time, where you've got the new accumulations, right? The buildup of new snow, and that's usually at the top where it's going to be colder, where you're going to get all the stuff falling and freezing and staying frozen. And then you're going to get this zone that's down from there, right? Less altitude, where it's going to warm up a little bit, and this is going to lead to some melting. You can even see in this picture there's a little meandering river at the bottom of this from all of the meltwater coming from that melting glacier. So even though it might be really cold, even though this glacier exists here, it still probably is melting to some degree, and that varies depending on the season you're in as well.
Right, so accumulation just means that it is the snow and ice that's building up.
Yeah, that's definitely a good SAT word. All right, and then the snow line is simply the boundary between the places where you're having more build up and you're having more melt. So that orange line up at the top here, between this accumulation zone where it is building, and then here they call it the ablation zone. That's where you get more melting than you get build up. So this might get some snow on it, but overall, if you look at the amounts of snow added and snow melting, more will melt in that ablation zone. So this line right here is that distinction of, okay, above it, there's more snow falling and building up, and here more snow is melting. So that's just called the snow line.
And visually too, where snow is accumulating, and ice also, it tends to look more like snow and ice, and where it's melting or ablating, it'll look a little bit darker because it's running water.
Yep. Here's just a quick side view. Oh, we got something in the chat. Russia, Canada, Norway, Finland. Oh, is that where you find glaciers? Yeah, super north or super south. Absolutely, you're gonna find them in places where you have high or low latitude for sure. So this is just a side view of what we were just looking at. So here, or I should say here, where we've got the accumulation at the top and then the ablation in the middle, and then you've got the water at the bottom. If you click to the next slide, here you see that accumulation at the top, and they even show you the extra snow coming down. It's slowly moving, and you can see here that there is more melting in that middle part. And here, instead of a river, they're showing that the ice is breaking off, or calving. That's the word for when it breaks off in these big iceberg chunks, and then they float away as the icebergs that maybe you're familiar with if you've ever watched the movie Titanic. So that's what an iceberg is. Iceberg is different than a glacier. It's a part of a glacier that broke off, and it's just free floating ice. Can't forget Iceland. For this slide, I'll move you up a little bit. There we go.
There we go.
I think it should look better now. Yep, now you can read it. All right, so last thing we'll talk about is the movement of glaciers. So it's kind of weird to think of, but you do have this ice that is flowing. And honey is not a terrible way to think of it, though honey moves really fast compared to it. So see how this honey builds up at the top and then blobs out on the sides? That's basically what's happening with the ice, just at a much, much slower rate. It's moving millimeters to meters a day. So over hours, it might move, small amount. But that isn't too far from how it moves. That it gets that snow deposited at the top, and then it moves out to the lowest region, just like water would, right? It always wants to go to the lowest part because of gravity. Same thing happens here with the ice, and here with the honey too. So you can see it's just moving out, and eventually that blob of honey would take over that whole plate.
Right, and that's representing a relatively flat area, so it's really not going to move super fast. Over time, it will flatten out the best that it can. But if you were to take that plate and kind of tilt it up, you would see the honey moving faster down the slope. And that's kind of the same thing that glaciers do. That would be your difference between a glacier forming on a continent versus a glacier forming somewhere in the mountains.
Right. So, yeah, going back to that point, the steeper that slope as well, the faster it will move. Again, just like a stream. If it's, like we were saying with a skateboard, if you're going down a really, really steep slope, you're going to be moving really, really fast because gravity is just pulling down and nothing's there to stop you, really. So you're just going to flow really, really quick. Or if you're on that skateboard, move really quick. Glaciers move faster in their center because that's where there's less friction, but also the most build-up. So if you're on this continental glacial area, right, this really flat area where you'll get a continental glacier, the middle part will most likely have the most snow, and it will go out just like this blob. But that is different if you're in the mountains, for sure. Lastly, as glaciers move, they scratch the bedrock, leaving striations, and they can crack the ground, forming crevasses, or they themselves crack, leaving crevasses. And we have some pictures of those. So this is a crevasse in that glacier, huge separation where it's just broken off. Pretty dangerous, but also pretty cool. And then glacial striations, these are in the bedrock. This is in the ground, so the glacier was here at some point in this picture, but it's not here anymore. And what happened was, when it was going over this area, and it was doing this flowing motion over, it had probably boulders and pebbles and all sorts of rock material. And it's like if you get a pebble stuck in the bottom of your shoe and you drag your shoe across the floor. It's going to push down and it's going to scratch into the floor underneath your shoe. Same thing with that glacier. It's going to have that rock in the bottom, all that pressure from all the weight, and it's going to just grind against the rock underneath it. So you can see from these different scratches the way that the glacier was moving. If you're taking it and scratching in one direction of the way you're going, you can trace that back. So this is kind of cool. We can look at places that no longer have glaciers and we can say, oh, the glacier probably was moving this way, and you can kind of trace that back to where it was moving from, and we get some interesting data about what glaciers were like in the past. Because nothing else really leaves those kind of scratches, naturally that is. It takes a lot of pressure. So I think that's it, except for the last part, which I kind of glossed over, which was when a glacier is melting, right? When it is not advancing, when it's not getting more snow and blobbing out over the plate, if it is melting more than it moves out, like that honey, we call that receding. So if it appears to be moving backwards, but really what's happening is it's still getting accumulations at the top and trying to blob out, but it's melting more at that bottom part, so it looks like it's pulling back. So again, we call that receding.
Right, so advancing means moving forward, receding means melting and the appearance of moving backward.
So we'll take a look at this on Wednesday, but Long Island was generally created from glaciers, and basically we just live on a giant mound that is just had been pushed from the glacier advancing, and then over time it got warmer and that receded, and well, here we are. And again, we'll take another look at that, the different things that we can trace back to see how we know that. But that has to do with this advance and retreat or receding.
And when a glacier is advancing or retreating or receding, that's when you're going to see the formation of the crevasses, which are the big kind of cracks and holes, and the striations, which are the scratches that show how the sediment is moving.
Cool. So that is the last of the slides for today. We will pick up the different features on Wednesday, just looking at all the different things that we can again trace back to glaciers. But this is just a little glimpse into what a glacier was and really how it works. So hope you found it interesting. Don't forget, folks, if you have questions about any of your assignments or just anything at all, we have our office hours. Mine are from 12:45 to 1:30, and then Astro has hers from 1:30 to 2:15.
And there will be links to both of our office hours posted in the stream in Classroom.
Yep. Also, just throwing this out there, that on Fridays, we are going to be having like a class social hour. So if you want to just pop in and see some familiar faces where you're going to have that open. I have the times posted. I forget them right now, but I'll post out more in the Google Classroom so that you guys can see when that's happening. We had a couple people stop by last time we had it on Friday, and it was nice to catch up and see what you guys are up to. So if you feel like hopping in, come say hi.
Yeah, definitely.
But other than that, have a good day, and if we talk to you later during office hours, cool. If not, maybe we'll see you Friday.
Yes, definitely.
Or Wednesday.
Yep, we'll
Whatever
be here
day it
Wednesday,
is.
we'll be here Friday.
All right, folks. Have a good one.
All right, enjoy the rest of your day, guys.